Hello, I'm Dr. Prem Kumar. Let us discuss about the linear hashing technique. It is one of the dynamic hashing technique. Linear hashing is an alternative of dynamic hashing technique. In dynamic hashing technique, you are having the concepts of extendable hashing and linear hashing. One is extendable hashing, the second is linear hashing. Already we discussed about the extendable hashing techniques. Now let us have a discussion on the linear hashing technique. There is a small difference between the extendable hashing and the linear hashing. In extendable hashing, whenever there is a overflow, there is a concept called overflow. Whenever there is a overflow, the bucket splits. Whereas in linear hashing, when there is a overflow, there is no hard and fast rule that bucket should get split. It depends upon the levels and rounds. We will discuss that with simple example. The purpose of linear hashing. It is used for faster fetching, searching the values. There are some thousands of values, lakhs of values. I want to search for a particular record. So without wasting time, immediately within no time, you can catch hold of that record with the linear hashing technique. With the linear hashing technique. It is one of the dynamic hashing technique. In dynamic hashing technique, the database grows. So whenever a new value comes, the previous values which are stored in the memory, they get adjusted. That is the advantage of dynamic hashing technique. And of course, we already discussed about the static hashing technique. In static hashing technique, whenever a value is placed, the value resides in the same position. But in dynamic hashing technique, whenever a new value comes, the old values will be adjusted depending upon the new value. So dynamically the positions of the existing values gets changed. That is the advantage of the dynamic hashing technique. Low overheads and splitting and merging. So number of times we will split the buckets and we will be merging the buckets. So while splitting and merging, whenever you delete, you will be merging. So the splitting and merging is a hectic process where in this linear hashing technique, the overheads are less. Efficient handling of overflow. So while overflow occurs, the buckets need to be splitted and the performance may get degraded in the different other hashing techniques, dynamic hashing techniques. Whereas the performance is perfectly maintained. With a greater performance, the overflow, whenever the overflow bucket occurs, the splitting takes with a great speed. So here there is a time complexity is being maintained. This linear hashing focuses both on the time complexity and space complexity. Better scalability, that is a support for incremental growth. Even if I put some lakhs of values, the dynamic hashing, that is a linear hashing technique, will accept the values and adjust those values accordingly. So there is a better scalability. You can increase the values or you can even decrease the values. The scalability is very high. Reduced fragmentation. It is a space complexity concept. Reduced fragmentation. More fragmentations leads to wastage of memory. Whereas here you are having the reduced fragmentation. So less fragmentation, less wastage of memory. So even the memory management can be done effectively, efficiently. Ease of implementation. So implementation is easy. The algorithmic implementation. The algorithmic implementation is comfortable when compared with the other hashing techniques. And performance in real-time environment. When the workload is more, when the workload is unpredictable, when the data is frequently occurring. So in real-time situations, you can do well with this linear hashing technique. There are different techniques and some are experimentally proved and that is fit for experiments. But for real-time applications, when you go with the real-time applications, this is the best technique. That is the linear hashing technique. Balanced query performance. The linear hashing aims to evenly distribute data on the buckets. So distribution data will not be skewed. So the distribution of data is even in every bucket. So evenness will be maintained so that the searching process becomes easy. Let us go with an example of linear hashing. Before going to an example, first point we need to know, we are using hashing functions. We will be using multiple hash functions. H0 is a hash function, key mod 2. Key is nothing but some data, data mod 2. H1, hash function 1, key mod 4. H2, key mod 8. So key mod 2, key mod 4, key mod 8. We will be taking buckets. What is this bucket? A bucket is nothing but it is a memory location. A memory location, I am calling it as a bucket. This is nothing but it is a bucket. And I am saying the size of bucket is 2. When I say size of bucket is 2, you can store 2 data values. So let me say I am storing 50 and 90, some data values. So the bucket can accommodate 2 data values. If I say bucket size is 4, it can accommodate 4 data values. If I say bucket size is 6, it can accommodate 6 data values. So this is called, the memory location is called as a bucket, and every bucket can hold some values. It is holding 2 data values. Let me say 50 and 90 are the 2 data values is being held by the bucket. Remember, when the bucket size is 2, you start hash function with 2. If the bucket size is 4, you start the hash function H0 with key mod 4. If the bucket size is 8, you start the hash function H0 with key mod 8. I hope it is clear. H0 is key mod 2, H1 is key mod 4, H2 is key mod 8, H3, suppose if there is H3, that becomes key mod 16, key mod 16. Suppose if there is H4, this is nothing but key mod 32, right? It's getting doubled, 2, 4, 8, 16, 32 and so on. Now we'll discuss a simple example. I am taking some input values, initial values 1, 16, 27, 27, 29, 18, 11, 22, 28, 9 and 14. Let us try this example. Here we are taking some values, initial values, and our hash functions. These are the different hash functions which I am going to apply. H0 is key mod 2, H1 is key mod 4, H2 is key mod 8. So the bucket size, as we discussed, I am taking initially 2 buckets. Here you can observe here bucket 0, bucket 1. I am taking 2 buckets and bucket size is 2. In each bucket you can store 2 values. You can store 2 values in each bucket. So 2 buckets and each bucket size is 2. That implies it can take 2 values into the bucket. Here I am starting with H0. Always we need to start with H0 initially. So here I want to store 1. 1 mod 2 is 1. Means that implies 1 is to be stored in the first bucket. 1 is stored in the first bucket. I am taking 2. Now I want to store 16. The next value to be stored is 16, second value. 16. 16 mod 2. I am using H0 mod 2. So 16 mod 2 is 0. So 16 is to be stored in the 0th bucket. 16 is stored in the 0th bucket. I am taking 20. 20 mod 2 is 0. 20 mod 2 is 0. 20 is to be stored in the 0th bucket. 20 is to be stored in the 0th bucket. 20 is stored in the 0th bucket. Now I am taking 7. 7 mod 2 is 1. 7 is to be stored in the first bucket. So the value 7, data 7 is stored in the bucket 1, in the first bucket. Now I am taking 27. 27 mod 2 is 1. 27 mod 2 is 1. Means 27 is to be stored in the first bucket. 27 is to be stored in the first bucket. 27 is to be stored in the first bucket. The first bucket is full because the bucket size is 2. Each bucket can hold only 2 values. But it is to be stored in the first bucket, and hence overflow chain. I am arranging a overflow chain with value 27. So this is nothing but it is a overflow chain. 27. Remember, whenever overflow occurs, there are 4 points to be memorized. Here, if you notice, I am using a next pointer at bucket 0. There is a pointer next to the bucket 0 which is pointing to the starting bucket, that is bucket 0. Whenever overflow occurs, The bucket which is pointed by the next is to be splitted. This gets splits, means this bucket gets duplicated, split, it becomes split. That's the first point. Second point, whenever a split occurs, the h0 gets incremented, the hash functions gets incremented, means the h0 becomes h1. And as there is a split bucket extra, there is a split bucket, this is bucket 2. Whenever there is a split bucket, this also becomes h1. So the hash function gets increased from h0 to h1. The third point is the values, the data values are to be rehashed with h1 function. h1 function is nothing but mod 4, key mod 4. So h1, the bucket which got split, the values, data values of that are to be rehashed with h1. The next point is, the fourth point is, the next will be pushed to the next bucket. So the next moves from here to here, the next pointer moves from here to here. That's what I'm going to do. You observe these 4 points. You observe here, what I done is, here the bucket 0, as it got split, it became bucket 2. Bucket 0, as it got split, it became bucket 2. The hash function got increased from h0 to h1, and these values are to be rehashed. The 16 mod 4 is 0, means 16 is to be placed in 0th position. 16 is already in 0th position. 20 mod 4 is 0. So 20 is to be placed in 0th position. 20 is placed in 0th position. Already it is in 0th position. Okay. The next should be moved to the next. So the next got moved to the next bucket. So this is what happened. Now I am inserting 29. 29 mod 2. I am using h0 hash function. 29 mod 2 is 1. 29 mod 2 is 1, means 29 is to be placed in first bucket. 29 is to be placed in first bucket, but the first bucket is full. It is already overflowed with 27. Now you place the 29 by the side of 27. Overflow occurred. Again overflow occurred. As I told you previously, whenever the overflow occurs, the 3 points to be observed. The 4 points are to be observed. The first point, the bucket with the next pointer gets split. Second point, the hash function gets increased. h0 becomes h1. And the data values are to be rehashed. And next moves to next bucket. The next moves to the next bucket. That's what I'm going to do. You remember the values 1, 7, 27 and 29. These values will be rehashed. See here in the next slide. Okay. You observe here. This h0 became h1. The bucket got split. As there is a result of split, here previously you are having only up to b2, now you got b3. The h0 became h1, it became h1. You can observe here h0 became h1. The values are rehashed. As a rehashed, 1 mod 4 is 1, 1 mod 4 is 1, and hence 1 is placed in first bucket. 7 mod 4 is 3, and 7 is placed in third bucket. 7 is placed in third bucket. 27, previously here there is a overflow chain. Here you are having 27 and 29. 27 mod 4 is 3. So 27 is placed in third bucket. 27 is placed in third bucket. 27 is placed in third bucket. 29 mod 4. 29 mod 4. 29 is placed, it is nothing but 1. That is 29 is to be placed in first bucket. 29 is placed in first bucket. Here there are no overflow chains. They got adjusted. The values got adjusted. Right? Now the next should move down, but remember, when all the hash functions becomes h1 from h0, when all the hash functions becomes h1, then round 0 is completed. We say round 0 is completed. There is no concept of h0. You observe here, this got converted to h1, 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 h1. The hash functions got converted to h1. Now we say when h0 is eliminated, we say round 0 is completed. Now we are entering into the round 1. Round 1 gets started. When round 1 gets started, the next pointer should not be moved to the next bucket. It should be moved to the first bucket. When round 1 starts, the next pointer should not be moved to the next bucket. It should be brought to the first bucket. That's what I'm doing. Okay, it is brought to the first bucket. Now, what I'm doing is, I want to insert 18 and 11. 18 mod 4 is 2. So 18 is to be placed in the second bucket. 18 is placed in the second bucket. Now I am inserting 11. 11 mod 4. 11 mod 4 is 3. So 11 is placed in the third bucket. 11 is placed in the third bucket. 11 is placed in the third bucket. Overflow occurred. Because the third bucket, it is already filled up with 2 values. The bucket size is 2. And hence when I am trying to place 11, you got an overflow. When there is overflow, the 4 points to be observed. The next pointer, we need to split the bucket with the next pointer. That is the reason the B0, now previously you are having B3, now you have got B4. The split occurred. Hash function is to be increased. The H1 became H2. The H1 became H2. Right? The values are to be rehashed. 16 and 20 are to be rehashed. 16 mod 8. 16 mod 8, H2 function, hash 2 function, 16 mod 8 is 0. 16 is to be placed in 0th bucket. 0th bucket it is placed. 20 mod 8 is 4. 20 is to be placed in 4th bucket. See here, the 20, which is previously in the 0 bucket, got moved to the 4th bucket. 20. Right? So, the next should move down to the next bucket. The next is moved down from B0 to B1. We will insert some value. I am inserting a value 22. Now I am inserting a value 22. The 22 mod 4 is 2. Means the 22 is to be placed in the second bucket. The 22 is to be placed in the second bucket. In second bucket we need to place 22. Right? It is being placed. Now I am inserting 28. 28 mod 4 is 0. 28 is to be placed in 0th bucket. Means you should get 28 here. Here, now you observe here, there is a specific condition. I am not placing 28 here. Why I am not placing? Means whenever you perform the hash function, you get a resulting bucket number. If this bucket number is less than, if the bucket number is less than the bucket which is pointed out by the next pointer, then it is to be rehashed with the next hash function. Once again I repeat, very sensitive point. I need to place 28. 28 mod 4 is nothing but 0. Means 28 is to be placed in the 0th bucket. So I should place 28 here, but I am not placing. The reason, whenever you perform a hash function, you will get a bucket number. If this bucket number is less than the next pointed bucket, because you got bucket 0, next is pointing to bucket 1, then this is to be rehashed with the next hash function. So the next hash function is nothing but key mod 8. So 28 mod 8 is nothing but 4. You got 4. So 28 is to be placed in the 4th bucket. Now I am placing 28 in the 4th bucket. You observe here. So this is a very sensitive point which is to be observed. Now I am taking a value 9 to insert. So 9 mod 4 is nothing but 1. So 9 is to be placed in the first bucket. 9 is to be placed in the first bucket. First bucket is already full with 2 values. Overflow occurred, and hence I placed 9 here. Whenever there is a overflow, so the bucket which is pointed out, the next pointer should get split, and hence you are getting the B5 here. The B1, the bucket, previously you are having B4. As the resultant of this split, the B1, you got B5, one extra bucket, you got one extra bucket. And the hash function H1 gets increased, it becomes H2. You observe here, you got H2. And the elements are to be rehashed. These values are to be rehashed. So 1 mod 8. 1 mod 8 is nothing but 1. So 1 is to be placed in first bucket. 1 is placed in first bucket. Next 29. 29 mod 8. 29 mod 8 is nothing but 5. So 29 is to be placed in fifth bucket. 29 is placed in fifth bucket. 9 mod 8 is 1, so 9 is to be placed in the first bucket. 9 is placed in the bucket 1. 9 is placed in the bucket 1, right? So now I would like to insert 14. I would like to insert 14 now. Now 14 mod 4. 14 mod 4 is 2. 14 is to be inserted in the second bucket. But the second bucket is full of values. So the bucket is full, and hence the overflow occurred. Whenever the overflow occurred, the bucket which is pointed out, the next pointer gets split, and hence you will get B6. And hence you will get B6, one extra, you are getting B6. And hence you are getting B6, extra bucket. The hash function gets increased, H1 becomes H2. So for bucket 2, the H1 becomes H2. The bucket 2, H1 became H2. Here also, you got H2. And these values are to be rehashed. 18 mod 8 is 2. 18 is to be placed in the second bucket. Already 18 is in the second bucket, right? 22 mod 8 is 6. 22 is to be placed in sixth bucket. 22 is to be placed in the sixth bucket. That is the reason I shifted 22 from bucket 2 to the sixth bucket. Next is 14 mod 8 is 6. 14 is to be placed in the sixth bucket. 14 is to be placed in the sixth bucket. In the sixth bucket I am placing 14, right? They got adjusted. You notice here all H1s are getting converted to H2. All H1s are getting converted to H2. Even if I insert some more values, this H1 will be converted to H2. When all these H1s gets converted to H2 all, then we will say round 1 is completed. Okay, now round 1 is not yet completed. Even if I insert some more values, then there is a possibility of converting this H1 to H2. When all these H1s gets converted to H2, then we will say round 1 is completed. When round 1 is completed, automatically the next pointer will not move next. It will go to the first bucket. It goes to the first bucket. This is how the linear hashing works. Now the point to be observed here is, what is the purpose of doing this? The purpose is for faster searching. As we discussed earlier, it is for faster searching. I want to search for a value. I want to search for a value 16. Let me say 16 mod 2 is 0. Means the 16 should be available in the 0th bucket. You observe here, is 16 available in 0th bucket? Yes. It is for faster searching. Suppose I want to search for 18. 18 mod 2 is 0. 18 should be in the 0th bucket. Do you have 18 in the 0th bucket? No. If no, don't become panic. Mod 4, you try with 4. So 18 mod 4 is nothing but 2. So it should be available in the second bucket. 18 is available in the bucket 2. Yes, it is available. Yes, it is available. Right? Suppose I want to search 27. 27 mod 2 is nothing but 1. So 27 should be available in first bucket. Is 27 available in first bucket? No. Then you go with a mod 4. 27 mod 4. When I go with the mod 4, you get 3. 27 should be available in third bucket. Is 27 available in third bucket? Yes, it is available. There may be lakhs of values, but you can catch hold of the value. Faster searching. First you perform mod 2. If not found, you perform mod 4. If not found, you go with the mod 8. Definitely the value will be available. If not available, in this case, that implies the value is not found. It is not existing. Right? That is the beauty of these hash functions. Right? Linear hashing. Thank you, students. Thank you very much.